Lecture 3 of 4, so 5.3, inverse function. So at the end of the lesson, students should be able to show whether a function has an inverse and find the inverse function, compute the inverse of a function, identify the domain and range of an inverse function, sketch the graph of the function f and its inverse on the same axis. So let's look at the box below here. So we have inverse function. So if f is a function from x to y, is a one-to-one function, okay, that maps from x to y, then the inverse function written by f inverse maps y back to x. So let's rewrite it again. So if we have f from x to y, so we can write it as fx equal to y. Similarly, so f inverse of y equal to x. Let this be number 1, this is number 2. So if we substitute, let's say 1 into 2, so we are going to substitute instead of y here, so we are going to substitute with fx. So f inverse of fx equal to x. So this is f inverse of fx equal to x. Similarly, if we have 2 into 1, so we will have f of f inverse y equal to y. So rewrite it in x form. So f inverse of x equal to x. Right. So this is actually f of f inverse x equal to x. So this one and this equal to this. That's how you get the formula. Right, if you look at the diagram here, so if f from x to y, so meaning this is the domain of f, this is the range of f. So next we have f inverse, meaning this is the domain of f inverse, this is the range of f inverse. So notice that domain of f equal to range of f inverse, range of f equal to domain of f inverse. So this is what it means by this, right? So just to make sure and just to restate it, so let's write it again. So df domain of f equal to range of f inverse, range of f equal to domain of f inverse. Right, this is also important. Okay, next, graph for an inverse function. Okay, the graph of an inverse function, okay, y equals to f inverse of x, can be obtained by reflecting it on the line y equal to x. So let's say if you have, this is the axis, x and y. So the line y equals to x is this line, y equal to x. Okay, so let's say if you have this curve as your fx, so you are going to reflect it on the line y equal to x, and you will get something like this as your f inverse of x. Okay, this example 17. Find f inverse, sketch the graph of f and f inverse on the same axis. Hence, state the domain and range for the f and the f inverse. So let's look at A. We have fx equal to 3x plus 6. So we need to follow the question. The question asks us to find the f inverse first. So how to get the f inverse? So remember to use f of f inverse x equal to x. So we are going to substitute, instead of x here, we are going to substitute with f inverse. So let's look at what I'm doing here now. So substitute, okay, if we have F inverse. So we have 3 F inverse of x plus 6, and that is equal to x. So rearrange 3 F inverse of x equal to x minus 6. F inverse of x is x minus 6 over 3. So that is another linear. Right? So let's look at the graph. So we're going to sketch the graph now for fx. So our fx just now, fx is 3x plus 6. So when x is 0, fx will be 6. When fx is 0, so we going to get 3x plus 6 equal to 0, x equal to negative 2. So find your negative 2. This is your negative 2. Find your 6, somewhere here, 6. Right, so let's use the ruler. So that's the graph. Let's draw the line y equal to x. So that's your line y equal to x. Let's label it. So y equal to x. So this is your fx. Right? So we are going to reflect on the line y equals to x for the fx. So if this is 6, so here it must be also 6. If this is 2, this is also 2. So let's draw it. So there you go, that's your graph. So label it f inverse of x. So this is your origin. So next, the question asks us to find the domain and the range of the f and the f inverse. Right, domain of f will be real number. Okay. Range of f also will be real number. So domain of f inverse, that's same with the range of f. So real number, range of f inverse, also real number. Right, let's look at B. Fx equal to x minus 2 bracket squared, where x greater equal to 2. So this is important. So if you have this, by right, you will know already that the graph, the domain will be, domain of f is 2 to infinity. Alright, so let's find the f inverse function by using f of f inverse of x equal to x. So let's substitute into your fx. Okay, so we will have f inverse of x minus 2 bracket squared equal to x. So how are we going to eliminate the squared here? So we're going to bring it to the right side. It becomes square root. So f inverse of x minus 2 equal to plus minus of surd x, or square root of x. Okay, so f inverse of x equal to plus minus surd x plus 2. But we are given already that x is greater equals to 2. So that is only the positive curve. So hence your fx, your f inverse x, is only surd x plus 2. Right, next, let's sketch it. So first, we need to draw the line y equal to x. Right, that's your line y equal to x. So label it y equal to x. So next, we're going to sketch graph of fx. So x minus 2 bracket squared. So we only want when x is greater equal to 2. So this is your 2. So let's say the curve will be something like this. So this is your fx. So next, we're going to reflect this graph fx on the line y equal to x. So if this is 2 on the y-axis, is also 2. So the graph will always be like this. So that's your f inverse. So this is your origin. So let's find the domains. The domain of f, that will be the same as range of f inverse. So domain of f is 2 to infinity. Right, let's write it nicely. 2 to infinity. And range of f will equal to domain of f inverse. that will be 0 to infinity. Right, part C, fx equal to x squared plus 4x minus 5, x less than equal to negative 2. So this is actually the domain of f. So since we have the function to be a quadratic function, so we need to do completing the square. So as we did earlier, so this is the easiest way to do completing the square. So bracket squared minus bracket squared. Okay, so we have minus 5. So half of 4, that will be 2. So x plus 2 minus 2 squared minus 5. So simplify further. So x plus 2 squared minus 4 minus 5 minus 9. So that is your fx. To get the f inverse, so we are going to use f inverse of x equal to x. So we are going to substitute instead of x here, so it should be f inverse. So meaning, so we are going to get f inverse of x plus 2 bracket everything squared minus 9 equal to x. So simplify further, plus 2 squared equal to x plus 9. So let's move to this side. So we have f inverse of x plus 2 equal to plus minus square root of x plus 9. Okay, not enough space, so let's rewrite it. So f inverse of x plus 2 equal to plus minus square root of x plus 9. So f inverse of x equal to plus minus square root of x plus 9 minus 2. So make sure that minus 2 is outside the square root. So, but you're given that x is less than equal to negative 2. So we want the negative part, the left side. So hence, your f inverse of x is, okay, the function will be f inverse of x equal to negative square root of x plus 9 minus 2. Next, let's sketch it. Okay, so first we need to draw the y equal to x line. The line y equal to x. There you go, that's your line. So label y equal to x. So the graph of fx, which is x plus 2 bracket squared plus minus 9. So we have the minimum point. So minimum point will be negative 2, negative 9. So we want the left side. So this is negative 2. So this is negative 2. This is negative 9. Sorry. So the graph will be something like this. So this is your fx. Make sure you label. So then we have to reflect it on the line y equal to x. So let's say this is negative 9. Here is negative 2. Right, this is the graph of f inverse of x. Okay, what is the domain and the range? So domain of f equal to range of f inverse, which is negative infinity to negative 2. Okay, and then range of f equal to domain of f inverse, which is negative 9 to infinity. Right, for d, fx equal to 1 minus x cubed. So x is less than equal to 0. So again, this is your domain of f. Okay, so negative infinity to 0. Right, let's find the inverse function. So f of f inverse of x equal to x. So let's substitute into the function. So 1 minus f inverse of x cube equal to x. So f inverse of x cube equal to 1 minus x. So f inverse of x equal to cube root of 1 minus x. Okay, let's sketch. So you need to draw the line y equal to x first. That's your line. So y equal to x, label it. So let's look at the fx. So we have the fx to be 1 minus x cubed. So when x is 0, so fx is 1. So find your fx1. So somewhere here. So let's sketch the graph. Right, label your function. So this is your fx. Next, reflect it on the line y equal to x. So find your 1 here. So this is your f inverse. So state your domain. So domain of f equal to range of f inverse. So we get it just now as negative infinity to 0. So range of f equal to domain of f inverse. So which is from 1 to infinity. Example 18. Find the inverse of the given function below and sketch both graphs on the same axis. Also determine the domain and range for the function and its inverse. Right, A. So fx equal to square root of x plus 2, x greater equal to negative 2. Okay, so find the inverse function. So f of f inverse of x equal to x. So we have square root of f inverse of x plus 2 equal to x. So how do we eliminate the square root? So by squaring both sides. Okay, you must show how you squaring both sides. Plus 2 here. So we get f inverse of x plus 2 equal to x squared. Okay, so we have f inverse of x to be x squared minus 2. Remember that you are given the values of your x for fx is x greater equal to negative 2. Okay, now let's sketch the curve, the graph, starting from the line y equal to x. So your fx is square root of x. Fx is square root of x plus 2. So when x is 0, so we have fx to be surd 2. Right, so here is your surd 2. So here will be your negative 2. So the curve will be something like this. So this is your fx. So this is your line y equal to x. So let's sketch your f inverse. So similarly, so this is your negative 2. And here will be your surd 2. Okay, so this is your f inverse. Don't forget to label your curve. So this is your origin. So next will be domain of f equal to range of f inverse, which is negative 2 to infinity. So range of f equal to domain of f inverse, which is 0 to infinity. Alright, let's look at B. We have fx equal to square root of x minus 1. So x greater equal to 1. So find your f inverse. So f of f inverse of x equal to x. So square root of f inverse of x minus 1 equal to x. Squaring both sides to eliminate the square root. So this is what you should get. Right, minus 1. So you get f inverse of x minus 1 equal to x squared. So f inverse of x equal to x squared plus 1. Just like A, so we need to draw the line y equal to x first. So that's the line y equal to x. Alright, so for your x, for your fx, so when fx equal to square root of x minus 1, so x greater equal to 1, so this is your 1. So the curve will be something like this. So this is your fx. And then similarly, when you reflect on the line y equals to x, the curve of y inverse and f inverse will be something like this. So this is your f inverse of x. So this is your origin. So hence the domain of f equal to range of f inverse, which is 1 to infinity. So range of f equal to domain of f inverse, which is from 0 to infinity. Example 19, sketch the graph of the function given and its inverse on the same axis. Hence, determine the domain and range for the function and its inverse. So if you notice, the function is a piecewise function. So there are two functions to sketch. So we need to look at the values of the axis given. So we have -3 and 0. So let's draw the line x -3 and x0 first. So this is x equal to -3. So this is x equal to 0. So on the left of x equal to -3 will be the function of this. This is a quadratic function. So if you look at that, so let's say fx equal to, so we arrange the position of the equation, so plus 3. So it is in completing the square form already. So we will get this is a positive curve. So we get the minimum point. So we need the minimum point. That will be -3, 3. So find your -3, 3. So here, so it should be on the left, right? So we don't have any equal sign. So this should be the blank circle, the empty circle. Okay, so next, between -3 and 0, we have the curve of fx equal to -x/2 plus 1. This is a linear equation. So when x -3, so you just substitute when x -3, what is your fx? So -3 divided by -2, so you get 3/2 plus 1, so you get 5/2. So when x is 0, so we get fx to be 1. So we need the 2 points. So this is just now 3. So this is 3. So half of it should be 5/2 is 2.5. So 1, 2, 2.5 somewhere here. So that will be here. So this is 5/2. And then when 0, it becomes 1. So here 1. This is 1. So this is also empty circle. Empty circle at 5/2. So let's join the 2 points. Okay, so that should be the curve of your fx. So label fx. So next, you need to draw the line y equal to x. So let's use blue for the line. So this is your line. So y equal to x. So label your origin. So this curve, your fx, we need to reflect it on the line y equal to x. So this should be this side. So let's draw it. So somewhere here will be 5/2. And then this is 1. So that's -3. So it should be somewhere here. Here, -3. Alright, so this is your f inverse of x. Okay, next, find the domain and range. So domain of f equals to range of f inverse. So domain referring to this value. So that will be -∞ to -3, union with negative 3, 0. Okay, let's write it again. Domain of f, range of f inverse, that will be negative infinity to negative 3. At negative 3, there's the empty circle, so that is open bracket. And then union with negative 3 to 0. So range of f will be equal to domain of f inverse. So what is the domain of f, the range of f? Look at here, the value, range of f from 1 to, so we have from 1 to 5 over 2, union 3 to infinity. Part B, gx equals to 2x minus 5 when x less than 2 greater equal to 1. Yeah, and then square root of x minus 2 minus 1 when x is greater than 2. Greater equal than 2. Okay, so first things first, so we need to draw the line x equal to 1 and x equal to 2 first. So this is your line x equal to 1 and then x equal to 2. So between 1 and 2, the graph will be gx equal to 2x minus 5. So when x equal to 1, gx equal to 2 times 1 minus 5. So we have negative 3. When x equal to 2, gx will be 2 times 2 minus 5. So we get negative 1. So identify where is your 1, negative 3. So let's say that's 1. Okay, roughly, so this is your point. So you have the equal sign at 1, so it's the shaded circle. And then at 2, it should be empty because we don't have any equal sign here. So 2, negative 1 somewhere here. So that is the empty circle. So let's join these two points. Right, next, the graph will be gx equal to square root of x minus 2 minus 1. So, of course, from here, under the square root, so we're going to get the x greater equal to 2. So that will be, so this is negative 1, so this is negative 3, so the graph should look something like this. So this is your gx. So let's draw the line x equal to y equal to x. So this is your line, label it, so y equal to x. So G inverse will be the reflection on this line, y equal to x. So we need to identify where is your y equal to 1 and y equal to 2. So just now we have negative 3, 1, negative 3. So this should be negative 3, 1. Right, and then one more, that will be 2 with negative 1, so negative 1, 2. So this should be empty circle. So let's join these two. Right, so this is number 2. This is negative 1. So, and then the other graph will be something like this. Okay, so this is your G inverse of x. So I haven't found the G inverse function, but I can always draw it by using the line y equals to x, the reflection on the line y equal to x. So hence, what is the domain of f? Domain of f equal to range of f inverse, which is, if we look there, 1 to infinity, and then range of f equal to domain of f inverse, which is starting negative 3 to infinity. Right, relationship between an exponential and logarithmic function. So if we have an exponential and logarithmic function, so what are the relationship between the two functions? So if we have fx equals to e power of x plus k, and then if we have another function, log of x minus k base a, so the statement here is if the function fx is an exponential function, so the f inverse will be the graph of log x minus k base a. Right, so the graph of the f inverse equal to log of x minus k base a is the reflection of the graph fx equal to a power of x plus k about the line or on the line y equal to x. So let's do some revision on how to sketch the graph, both graphs. So if we have fx equal to a power of x plus k, so we have a method here to use IQA. So I means the intercept, Q will be the quadrant, A will be the asymptote. Right, so if you look at this, so intercept when x is 0, so you will get fx to be a0 plus k. So you get k plus 1. That will be the value of your y, fx equal to y equal to fx. So quadrant, so we are looking at the sign of the x here. This is positive, and then this is also positive, meaning the fx also positive. So plus here, and then the asymptote comes from here, which is the horizontal asymptote. So horizontal asymptote will be x equal to y equal to k. So knowing this, so we're going to sketch the graph. So find first your asymptote. So let's say this is your y equal to k. So we have here k plus 1 for the intercept, and then we have the point plus here. So we're going to join everything. So that is the graph of your fx. So similarly, so if you were to sketch the graph of your f inverse, so first you need to sketch the line y equal to x. So if we have the f inverse of x will be log of x minus k base a. So again, I, q, a. I for the intercept. For this case, if we have if y equal to 0, or if the f inverse, if y equal to 0, so we get x equal to k plus 1. So quadrant, again, this is positive, this is also positive. So positive, positive, and the asymptote comes from inside here, inside the bracket, which is x minus k cannot be 0, so x cannot be k, so meaning x equal to k will be the vertical asymptote. So we need to get the vertical asymptote. So this is your vertical asymptote, which is x equal to k. So this is x equal to k, so the intercept will be k plus 1. So this is your positive, positive. So the graph will look something like this. So this is your f inverse of x.
Example 20. Given that fx equal to ln 4x minus 3, show that fx is one-to-one function. By using algebraic method, we can show that the fx is one-to-one function using substitute x1 and x2. So first function, we substitute x into x1 equal to second function where the x we substitute with x2. To eliminate exponent, to eliminate log, we must exponent both sides. So exponent and ln, we can get 4x1 minus 3 equal to 4x2 minus 3. And then we simplify, we can get minus 3 plus 3. So 4x1 equal to 4x2. And then we divide 4. We can get x1 equal to x2. Therefore, f is one-to-one function. Okay, question B. Find an expression for f inverse. By using properties of f inverse x equal to x, we substitute x into f inverse. So we can get ln 4 in the bracket minus 3 equal to x, and then we substitute x into f inverse, and then make f inverse as a subject. So we have ln here. So eliminate with exponent. We exponent both sides. So we can get 4 f inverse x minus 3 equal to exponent x. And then 4 f inverse x equal to ex plus 3. And then f inverse x equal to exponent x plus 3 over 4. So this is our inverse function. For question C, determine the domain and range for f and f inverse. So for C, our function f is ln 4x minus 3, and our inverse is exponent x plus 3 over 4. From fx, we know that the function is ln. So the domain for ln, we must take the value inside the ln and must be greater than 0. So x must be greater than 3 over 4. So this is our domain for f, which is domain f equal to range for f inverse means greater than 3 over 4 or 3 over 4 until infinity. And we know that range for f for ln is equal to domain f inverse, which is the value is negative infinity until infinity.
Right, for 20D, example 20D, so we are required to sketch the graph of fx and f inverse on the same axis. So let's write down the function again. So fx equal to ln of 4x minus 3. And then your f inverse of x will be exponential of x plus 3 over 4. So let's use the IQA method. So for fx equal to ln of 4x minus 3. So I for the intercept. So when fx equal to 0, so meaning ln of 4x minus 3 equal to 0, 4x minus 3 change to index form E0, so that will be 4x minus 3 equal to 1. So 4x equal to 4x equal to 1. And then for quadrant, so we are looking at the signs of the x, and the fx. So again, this is referring to this fx. So this is plus. So the quadrant will be plus plus. So plus plus here. And then for A for the asymptote. So from where do we get the asymptote? So that will be from the inside the log. So 4x minus 3 cannot be 0 for log. So x cannot be 3 over 4. So your vertical asymptote will be x equal to 3 over 4. Right? Knowing this, We need to know this first before we sketch. And then similarly for f inverse of x, we have here you need to split the denominator, so e power of x over 4 plus 3 over 4. And then again, so I, the intercept, that is when x equal to 0, so the f inverse of x, we will get E0, that will be 1 over 4 plus 3 over 4, so you get 1. So, and then Q for quadrant, again this is positive, and then positive in front here. So, positive, positive. And then for the asymptote, so we will get y equal to 3 over 4. So, this is your x-axis, y-axis, the line of y equal to x. So let's sketch your fx first. So we have the vertical asymptote to be here x equal to 3 over 4. So the intercept will be 1. So it will be positive, positive. So the graph will be something like this. So this is your fx. And then for your f inverse, find the value of y equal to 3 over 4. So this is your y equal to 3 over 4. And then also the intercept will be 1. Okay, it is also positive, positive for the quadrant. Right, this is positive, positive. So this will be your f inverse. So label it.